All right, let's talk about one of the absolute cornerstones of the internet as we know it, Amazon's EC2. It's kind of like the invisible engine that powers a huge chunk of the web, and by the end of this, you're going to understand exactly what it is, and more importantly, why it's such a game changer.
So have you ever stopped to wonder, what's the secret sauce? How does a company like Netflix stream billions of hours of video? Or how does Airbnb manage millions of bookings, all without owning some giant physical server farm themselves? How do they handle those massive, unpredictable spikes in traffic?
Well, the answer isn't some crazy secret. It's actually a really simple but incredibly powerful idea. At its very core, it's all about renting compute power. That's it. You're renting a virtual server in someone else's massive, state-of-the-art data center. And that idea, right there, is what makes the cloud possible.
And that brings us right to the service that started it all, Amazon EC2. It stands for Elastic Compute Cloud, and it lets you do just that. You can rent virtual servers, which, by the way, AWS calls instances, in their data centers all over the world. And here's the really revolutionary part. You only pay for what you use, often billed right down to the second. No long-term contracts, no buying expensive hardware.
So, when you decide to rent one of these instances, what are you actually getting? Let's pop the hood and take a look at the anatomy of a virtual server. We're going to break down the core components.
Everything, and I mean everything, starts with the software blueprint. This is called an Amazon Machine Image, or AMI for short. Just think of it as the master template for your server. It's what holds the operating system, like Linux or Windows, and it can also have any software you want already pre-installed.
Yeah, a golden image is the perfect way to think about it. You can start with a totally clean slate, like a basic Ubuntu AMI, or you can get everything set up just the way you like it. Install your web server, your application code, and then save that as a custom AMI. It makes launching new, perfectly identical servers incredibly fast.
Okay, once you've got your software template picked out, you need to choose your hardware. In the AWS world, this is called the instance type. This is where you decide how much horsepower your server is going to have, how many CPUs, how much memory, and how much networking muscle it needs.
And let me tell you, there are a ton of options. You could start with something really small, like a T3.micro, which is perfect for just testing things out. Then you could move up to a general-purpose instance like an M5.large, which is great for web servers. Or, if you're doing some serious number crunching, you might grab a CPU-intensive instance. It's all about picking the right tool for the job.
Next up, storage. Where are you going to keep your files? EC2 gives you two main options. The one you'll use most of the time is called EBS, or Elastic Block Store. This is persistent storage. That means your data is safe and sound even if you stop or restart your server. It's perfect for things like databases. Then there's Instant Store. This is temporary. It gets wiped clean when the server stops. It's super fast though, so it's great for things like temporary caches.
Okay, so we've picked out our software and our hardware. But how does this server actually talk to the internet? And maybe more importantly, how do you keep it safe from all the bad stuff out there? This is where networking and security become absolutely critical.
Your instances don't just float around in space. They live inside something called a virtual private cloud, or VPC. Just think of it as your own private, fenced-off neighborhood in the giant city of the AWS cloud. Inside that neighborhood, you can give a server a public IP address so anyone on the internet can reach it. Or you can give it a private IP so it can only talk to other servers inside your neighborhood, perfect for a database you want to keep hidden away.
So how do you control who gets into your neighborhood? You use a security group. And honestly, the best way to think of this is like a bouncer at a club. It's a virtual firewall for your server. You create a guest list, a set of rules that says, okay, web traffic can come in on port 80, but only from these places. If a request isn't on the list, it gets denied. Simple as that.
So we've covered the compute cloud part of EC2. Now let's get to the real magic, the elastic part. This is what changes everything. It's all about how you can scale your servers up and down instantly, and how you pay for them.
So AWS gives you a few ways to pay. On Demand gives you the most flexibility. You pay by the second, no commitment, turn it on and off whenever you want. If you know you're going to need a server for, say, a year or 3, you can get a huge discount with reserved instances. And then there's spot instances, where you bid on spare AWS capacity. You get the deepest discounts, but the catch is AWS can take the server back with a short notice.
But what happens when your website gets really popular and one server just isn't enough? That's where a load balancer comes in. It sits out in front of all your servers and basically acts like a traffic cop. When a user's request comes in, the load balancer intelligently sends it to one of your healthy EC2 instances, making sure no single server gets overwhelmed.
Now, this is where the real magic of elasticity comes to life. You can take that load balancer and combine it with something called an auto-scaling group. This group is like a thermostat for your servers. It watches your traffic, and if things start getting hot, it automatically adds more servers. Then, when things cool down, it removes them. This means your app is always fast, and you literally only pay for the exact compute power you need at any given moment. It's incredible.
So we've covered all the individual building blocks. Now let's see how they all fit together in a real-world scenario.
This right here is a classic, super powerful setup. A user's request from their browser first hits the load balancer. The load balancer then sends that traffic to one of the EC2 instances in your auto-scaling group. That instance, running your application code, then talks to a separate database, maybe something like Amazon's RDS, to read or write data. It's a simple, incredibly scalable, and really reliable design.
We have covered a ton of ground, so let's wrap this all up with the final verdict on EC2. When should you use it, and what are the trade-offs you need to think about?
The biggest advantage of EC2, hands down, is control. You get the keys to the kingdom. You have full root access, full control over the operating system, all the software, everything. But with that great power comes great responsibility. You are now the one in charge of managing operating system updates, security patches. You're responsible for the health of that server.
It's also really important to know where EC2 fits in the bigger AWS picture. If you need that total control over a server, EC2 is your guy. But if you just want to run some code and not even think about servers, well, that's what AWS Lambda is for. If you're working with containers, you look at ECS or EKS, and for a super simple all-in-one package for a small website, there's a service called Lightsail.
So here's the bottom line. If there's one thing you take away from this, it's this. EC2 is your go-to choice when you need, or want, full, granular control over the entire environment. When you want to get your hands dirty, manage the machine yourself, install some custom software, and really fine-tune the OS, EC2 is the perfect tool for the job.
And that, in a nutshell, is EC2. It's an incredibly powerful building block that gives you the flexibility and the scale to build pretty much anything you can dream up. So the only real question left is, with access to virtually unlimited computing power right at your fingertips, what are you going to build?